Good morning, class. So at this point you got your test back. Okay, so you're going to be twice as quiet as you were before. Alright, so we're going to go through that paper first. I'm going to show you how to get 28 marks. Okay, or close to that. Okay. So the first question says expand and simplify as far as possible. So this of course is your cos expansion. So the cos expansion is cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. So what is your alpha angle here? 60. So it's cos of 60 cos of x plus sine of 60 sine of x. Now people, 60 is a special triangle. Not so? So you draw a special triangle that is 30, 60, 1, 2, root 3. Cos of 60, 60 is adjacent over hypotenuse cos of x plus sine of 60 is root 3 over 2 is opposite over hypotenuse sine of x. Okay, and as you can see the LCM is 2 there, so it's just simply going to be cos x plus the root of 3 sine x. Okay, this came straight out of the exercise 2 out of the platinum textbook. Okay, this one as well comes out of the same exercise. You can go find it if you like. It says simplify as far as possible. So we got sine, sine, cos, cos. So what I'll do is, which rule is that? Sorry, sine, sine, cos, sine is none of the rules. However, sine, cos, if this was a cos, then I would have used the sine rule. Not so. Otherwise, I could have kept that sine, sine and changed the sines to 160 to a cos of something. And then put that first. Because the rule says cos, cos, sine, sine. So I'm going to do both ways because I know some of you went with the cos rule. So I'm going to first change that to cos. So it's going to be sine. How does sine change to cos? It will change on the co-function. So it's 90 minus 20. Not so. So that is going to be 90 minus 20 is simply cos 20 plus, that is in the fourth quadrant, that is 360 minus 10, which is cos 10 degrees, which now has your alpha angle in place. Now 160, I could have said 90 plus 70. But because it's a 20 degree here, can you see the 20 degree? So I'm going to try and rope in 20 degrees off that one. And we can then simply say it's going to be sine 180 minus 20 is going to be sine of 20. Can you see there the sine alpha cos beta plus cos alpha sine beta? You see that prevailing there? So this is sine alpha cos beta plus sine beta cos alpha, or cos alpha sine beta. That is the sine rule, sine alpha plus beta. So this would simply be, your alpha is 10 and your beta is 20, which is simply sine of 30, which is 1 over 2. Okay, that's 1 over 2. Otherwise, if I had gone with the cos rule, so the cos rule says sine, cos, cos, sine, sine. Cos alpha plus or minus beta is going to be cos alpha cos beta sine alpha sine beta. So if that is plus, that is minus. If that is minus, this is plus. So you see sine is second. Can you see that, people? So I'm going to put that straight away second. Okay. However, 350, I need to use I need to pick up 10 degrees there. So that is simply cos of 360 minus 10. So it's cos of 10 degrees. This here, sine. Now I need to change that to a cos. Why? Because it's cos, cos, sine, sine. And how can I change that to a cos? If you're going to say sine 90 plus 70. Then which quadrant is that in? Second quadrant. Is sign positive, negative in the second quadrant? Positive. Although it changes to cos of 70. Alright. So, cos alpha cos beta plus sin alpha sin beta is going to become cos alpha minus beta. Can you see that? So in other words, it's 10 minus 70. What is 10 minus 70? Negative 60. Which quadrant is negative 16? Which quadrant is negative 16? Okay, if it's a negative angle, what do we do? Add 360. So what is 360 minus 60? Which quadrant is that in? Fourth quadrant. Is cos positive or negative? Positive. Cos 60. We get into our special triangle. So it's 1, 2, root 3. Cos is 1 over 2. Which is the same answer as we had before. Whichever one you prefer using will get you the right answer. You should have gotten you the right answer. Let's go to the next one. It says evaluate without using a calculator. But what do I see here? I'm already seeing something familiar there. Not so? What does that remind us of? Cos squared alpha minus sin squared alpha. Why both alpha? Because both angles are the same. What does cos squared alpha minus sin squared alpha remind us of? Cos 2 alpha. So in other words, this is going to be cos 2 times 15. Now what does sin alpha cos alpha remind us of? If there's a 2 there, it reminds us of sin 2 alpha. That's all. So in other words, I'm shorting a 2 here. So if I put a 2 in front of it, what must I do? Divide by 2 as well. Or you can say, this is going to be safer because I see some of you are pulling your faces already. Or it's going to be safer for you to say that to get this on its own, I divide by 2 both sides. So sin alpha cos beta cos alpha, sin alpha cos alpha is equal to a half sin 2 alpha. You see that? So cos 2 to 5 sin 2 to 5 is then equal to a half times sin 2 times 22.5. Okay. So that is simply what? Cos of 30 plus a half sin of. What's 22.5 times 2? 45. Not so? So sin 45 goes to the special angles there. And cos of 30 also to the special angle. So it's 31 to root 3. It's going to be a root 3 over 2 plus a half times sin 45. So it's 1 root 2. So it's 1 over root 2. Okay? I would have given you full marks there. But if you go further, your LCM here is going to be 2 root 2. So that must be multiplied by root 2. So it's going to be root 6. That must be multiplied by 1. So there we go. So root 6 plus 1 over root 2 root 2. If you want to rationalize the denominator, it's going to be 2 root 3 plus root 2 over 4. I think. Yeah. Okay. Any confusion here? Again, people, you'd okay, this also came out of that exercise. Okay, out of the, I think it was exercise, no, that's double and compound. No, it was all double. So it comes out of the exercise we're currently busy with. Well, we just completed yesterday. The next one is just prove the given identity. Okay. So, the left hand side of course is more complex. Sin 2x So that comes from the identity sine 2x is equal to 2 sine x cos x. People, that one is a giveaway. It's the first thing you write down if you see that. Minus. Now tan can be written as sine over cos. Sine x over cos x. And this is all over cos 2x. Okay? Okay, I'm going to leave that blank for now. What's my LCM here? Sorry? Cos x. So in the numerator, LCM is cos x. Remember the denominator I'm going to fill in now. So it's 2 sine x cos squared x minus sine x over that we're going to fill in now. If you're looking at the numerator, what do you notice? Sine x is a common factor, not so. So you got sine x into 2 cos squared x minus 1 over cos x all over what I'm going to fill in here now. Now if you look at cos 2x, cos of 2x can be written as 2 cos squared x minus 1, 1 minus 2 sine squared x, and cos squared x minus sine squared x. That's all. So which one do you think we're going to use? The one dealing with 2 cos squared x minus 1. Why that one? You can cancel this here. So now just writing 2 cos squared x minus 1, 2 cos squared x minus 1, 2 cos squared x minus 1. Remember, I'm dividing those two so I can multiply it. So that cancels that. Not so. So what are we left with? Sine over cos, which is equal to tan x, which is equal to the right hand side. People, you are definitely going to get the sum like this in your exam. So do a lot of this. Okay, and this is the exercise you currently busy with. Okay? This also comes out of that exercise. Then we are told, I think I must pull this up. Then we are asked, I need this, keep that. Okay, they want to know for which values of x is the given identity invalid. So invalid or undefined is the same thing. Not so. So when is a fraction undefined? Is when the denominator is equal to 0. So in other words, is where cos 2x is equal to 0. Can you see that's your denominator? So now if it's 0, 1 and minus 1, we take it to the cos graph. So remember this is a 2x here. So this graph completes itself in 180. So cos of 2x is 0 at this point here, which is 45, and at that point, which is 135. Can you see that? So to write that as a general solution, x is equal to 45 plus k times 180, or x is equal to 135 plus k times 180, where k is an element of integers. Okay. Or if you look at this closely, you will see that this solution actually repeats itself every 90 degrees. So instead of writing this here, I could have said once x is equal to 45 plus k times 90 degrees, where k is an element of integers. Okay. So that is for where the denominator is equal to 0. If you see here on the other side, we also have a tan. So tan has What do we call those lines? In a tan graph, asymptotes. Not so. So the tan graph has asymptotes, and the asymptotes are also invalid points or undefined markings on the graph, where the graph is undefined. So where's the graph undefined in the tan graph? We're looking at the tan graph, it is at 90 degrees. The next one is at 270 and so on. So this will be undefined where x is equal to 90 plus k times, and this happens every how many degrees? 180 degrees. And by saying this once, suffice for everything in that question. Okay. It's enough for all that in the question. 2 marks for this question, 1 in each branch there. We go question 5. In question 5 we are told, given that cos of A is equal to negative 3 over... People, you must be able to do this. To draw a diagram. Some of you draw the diagram wrong. You can't get this wrong after 2 years of Trigs. Okay? And it's a definite question. Okay, it comes often in. So this tells us that cos is negative. In which quadrant is cos negative? Second and third quadrant. Now we are told that A is an element of negative 90, so there's negative 90, 0, 90, 180, 270 and so on. We are told it's greater than negative 90, so I'm going in that direction. Greater than negative 90, but less than 180. So in which quadrant does it have 2 ticks? In quadrant 2. So I have to draw it in quadrant 2. This is there's an A, so it's A here. What does cos stand for? Adjacent of hypotenuse. So it's going to be 3 and 5. 5 will never be negative. So that negative actually belongs to the 3. So how do we get the third side? Pythagoras. So how do I apply Pythagoras? It says 5 squared is equal to negative 3 squared plus your opposite side squared. So your opposite side squared is equal to 25 minus 9, which is 16. The square root thereof, your opposite then works out to be 4. Can it be negative 4? No. Why? Positive part of your x-axis. Y-axis. Okay. So the question says determine without the use of a calculator tan of 2a. Now do I have an identity for tan of 2a? No. So I then break it up. Tan can be written as sine 2a over cos 2a. Can I use that for the diagram still? Not yet. Not so. However, sine can be written as 2 sine a cos a. Cos 2a can be written as any one of the 3. I'm going to go with 2 cos squared a minus 1. As I said, you could have used any one. Okay? So that is simply 2 sine a cos a over 2 cos squared a minus 1. So sine a, sinus, opposite of hypotenuse, so it's 4 over 5. Cos is adjacent of hypotenuse, is negative 3 over 5. Cos of a, cos is adjacent of hypotenuse, negative 3 over 5. Okay. So this here I can put in a calculator. You will see without the use of a calculator, there's actually a way of calculating the angle of A and then just doing the substitution. You'll get exactly the same answer. That is what they want you to do. Okay. So this here you can put in a calculator because from here to the answer is 1 more. So it's 2 into 4 over 5 into negative 3 over 5 over 2 open brackets negative 3 over 5 squared minus 1. You get 24 over 7. Okay. The next one is cos of 2a. Cos of a over 2, sorry. cos of A over 2. So, if you look here, there's no link. It feels like there's no link between A and A over 2. But A over 2 also can be written as a half A. Not so. So if you're looking at the cos 2A, cos of 2A is going to be 2 cos squared A minus 1. Not so. But if A, sorry, suppose I put alpha here. I mean to put alpha. Okay, so if alpha, you see, if alpha was A over 2, then that would simply be 2 cos squared A over 2 minus 1 into cos 2 into A over 2. You see that? So your alpha angle is A over 2 here. So exactly the same thing. So what is A over 2 times 2? It's just A. So it's cos A equals 2 cos squared A over 2 minus 1. But what is cos of A? Cos of A is adjacent of hypotenuse, which is negative 3 over 5 equals 2 cos squared A over 2 minus 1. So we take it over the equal sign. It becomes negative 3 over 5 plus 1 is 2 over 5 is cos squared A over 2. To get rid of the square, square root both sides. So cos A over 2 equals plus minus the root of 2. Okay. And the last one.
So,
yes? Okay, right? Okay. In the question 6, in the diagram not drawn to scale, BC is parallel to. So if BC is parallel to EA, then ND over DB is equal to NA over CA, as well as MB over BE is equal to MC over CA. I expected everybody to get full marks for this because this section we have written on it. Okay, in your cycle list. Okay, so if MA, I'm going to divide both sides by MN. So it's going to be 3 over 8. So MA is going to be 3K. MN is going to be 8K. So NA is 5K. Okay. Then we have MB, divide both sides by BE, and then both sides by 2, we get 1 over 2. So MB is going to be A, BE is 2A. And I'm going to use K again because that's on the other side of the triangle. Okay. The question is find the value of BD is to DN. But we know that BD over DN is equal to CA over AN. But I don't have CA. Can you see that? So I must calculate CA first. Okay. But CA is falling in this triangle here now. So CA over AM is equal to EB over EM. Okay? So I'm going to say CA over AM is equal to, why not CM? Because the CM is not more. However, I know AM is 3K. That's why I'm going with the whole. So CA over AM is equal to BE over the whole length of ME. The reason is the proportionality theorem with EA being parallel to BC. So CA over AM is 3K equals BE, which is 2A over 3A. So you cross multiply, so CA is equal to, the A's cancel, the 3's will cancel, which will leave you with 2. 2K. Okay, so that's going to be 2K. And that's enough information to conclude. Therefore, BD over DN is equal to, so BD over DN is equal to CA over AN. Again, the proportionality theorem with EA being parallel to BC. So CA is going to be 2K over AN, which is 5K. So therefore BD to DN will be 2:5. Okay. That's how you get 28 marks. Alright. As I indicated before, these sections, it's not going, you're never going to figure it out in the exam. No, you must practice and practice and practice a lot. Okay. So I can delete that. Then yesterday we dealt with trigonometry. What was the homework for today? Exercise 5. The whole exercise. I said we're going to look at the examples of this, no? Right, let's look at the worked examples. This is on page 101. So your homework for today again. You guys managed to solve all that? No. So your homework for today again is only the odd numbers. Tomorrow's lesson we'll look at the odd numbers again. Okay. So we're just going to look at the examples, but then the balance is going to be again. Alright. So people, which side do you want me to work with? Left hand side or right hand side first? Sorry? Looks like I'm going to work both sides, isn't it? So let's go with the left hand side. What can be done on the left hand side? Cos can change. So cos 2x can be written as 1 of 3. Is 2 cos squared x minus 1. 1 minus 2 sine squared x. And cos squared x minus sine squared x. Then we know that cos 2x can, sine 2x, sorry, can be written as 2 sine x cos x. Okay. So which one of the three you think we're going to use here? 1 minus 2 sine squared x. Why? So that I can get rid of the 1. Not so. So you're going to become 1 minus 2 sine squared x. So that becomes what? 1 minus 1 plus 2 sine squared x. So that cancels, not so? So it's going to be 2 sine squared x. Now let's look at the right hand side of the equal sign. What can happen here? What can happen there? Tan can change. Tan can be written as sin x over cos x times sin 2x, 2 sin x cos x. And this is over Now what do we do? Cancel. Cancel what? Cos x. So what are we left with? 2 sine squared. What do you notice now? It's equal to the left hand side. Okay, is there any confusion, people? Huh? You guys understand? Should I do it again? No. Okay? Look at number 2. In number 2, we are asked to prove that cos 2x over 1 plus sine 2x is equal to cos minus sine, cos x minus sine x over cos x plus sine x. Which side do you think we're going to work with here? Left hand side. Okay? So to expand this is going to be easier than to reduce it. Okay? So the left hand side. It's not impossible, but it's just complex. People, let's look at the denominator. That there is a definite. That can be written as 2 sine x cos x. Okay? What can happen to the 1? 1 can be written as sine squared x plus cos squared x. Not so? So write that in. That sine, that 1, we see it can be written as sine squared x plus cos squared x. Why do you think I'm writing it like this? Yes? Trinomial. Did I understand? Yes, absolutely. This is a perfect square trinomial. So it's going to become cos x plus sin x times cos x plus sin x, which is cos x plus sin x squared. How do I know I was going to that? Because of what is on the side. I always keep my eye on the left and the right hand side. Okay. Let's look at the numerator here. Which one of the three you think we're going to choose there? Cos squared x minus sin squared x. Why? So that you can apply the difference of two squares, which will be what? What will this be? Cos x plus sin x, cos x minus sin x. Now what? What can happen now? Cos x plus sin x cancels cos x plus sin x. That's all. There's 2 in the denominator, so it cancels one of the 2. So the answer is cos x minus sin x over cos x plus sin x. What do you notice now? Equal to the... Okay. Let's do the last example before we leave. People, which side is more, do you think you're going to work with first? It looks like you're going to work with both. But which side do you think we're going to start off with? The right hand side. Okay. So what's going to happen here? Which one do you think you're going to choose here? Cos 2x can be written as 1 minus 2 sine squared x. Why? Sorry? 1's can cancel. So it's 1 minus, we're going with this one here. So it's 1 minus into 1 minus 2 sine squared x over, which one are we going to choose in the denominator? Sorry? 2 cos x squared x minus 1y. The 1's can cancel, not so. So now we get rid of the bracket. So it's 1 minus 1 plus 2 sine squared x over, the 1's cancels, not so. So it's 2 cos squared x. Now what? What can happen now? The 1's cancels, not so. Sold up. So that cancels, not so. So what do we have? 2 sine squared x over 2 cos squared x. 2's cancel. What is sine over cos? Tan. And sine squared x over cos squared x? Tan squared x. Which is actually equal to the left hand side. Okay. People, you're definitely going to get a sum like this in your exam, your final exam, your mock exam, this upcoming control test, your June exam. So learn it, people. It's going to be worth a minimum of 4 marks or 5 marks. Okay. I think the minimum on this question is 4 marks. People, enjoy the rest of your day. Good morning, class. Don't forget the homework is exercise 5. The odd numbers, okay? Wat gaan er nou aan? Huh?